Good morning, Asandi. Okay, so I've just done both the questions. The second question I've got wrong, mainly because I had a disaster in it, and I haven't rubbed anything off the board because the first question is completely right, and I'm happy with my answer there. Um, I'm just loath to rub it all off and then write it all down again because it's going to do my head in. So let me just talk to you about the first question, 1E. I I think I know what bugs you about their answer here is the fact that it probably doesn't look like your answer, even though your answer is completely correct here. Okay, now let me talk through what I'm going to do. I'm going to end up with exactly that answer, but it's going to be without this minus 32 on the end, and that's probably what's bugging you, that number. Well, don't worry, you've done everything right probably, and you're just a little bit confused with the look of their answer at the end. So anyway, this first question. Obviously, we've got to write in partial fraction, and this is a partial fraction which I would call top-heavy because it's cubic over quadratic, which means the format needs to be like this. Because you're doing cubic divided by quadratic, you're going to end up with a linear plus c over x minus 4 plus d over x plus 2. You've got to get that format right firstly, or you're going to get nowhere in this question. We can then multiply that across. So we've got this, and then we can proceed as normal, saying let x equal 4. That knocks out this term, and this term. And this term, and means we can deduce c. We get c is 32 over 3. We can then let x equal minus 2, and it knocks out this term, and this term, and we can work out d. D ends up being 4/3. By inspection, we can just say, well, a is going to be 1 because you're doing x cubed divided by x squared. So that gives you a is 1. And then you could, for example, let x equal 0. It knocks out, well, it doesn't knock out, it knocks out the first term, but it doesn't knock out this one or this one. So you're left with 0 equals minus 8b plus 64 over 3 once you've done the 2 times c, minus 16 over 3 once you've done the minus 4 times 4/3. Solve that, you get b is 2. So we're actually integrating at the end, we're integrating x plus 2 plus 32 over 3, 1 over x minus 4, plus 4/3, 1 over x plus 2, with respect to x. And we can directly integrate all of that without thinking really. X squared over 2 plus 2x plus 32 over 3 ln x minus 4 plus 4/3 ln x plus 2 plus a constant on the end. Now, our constant isn't the same as their constant, the answer. And that's why I called it plus c first, and then I've crudely gone over the top in pen and called it plus k instead, because our answer is the same as their answer. We get x squared divided by 6, you get x squared over 2. Once you've done 3 times 4x over 6, you get 2x. You get all the same terms. The 64 over 6 is 32 over 3 ln x minus 4. The 8 over 6 is 4/3 of x plus 2. The only thing which is different is this minus 32, which after you've times by 3 and divided by 6 is minus 16. Well, just let your k equal c minus 16, and you've then got exactly the same answer as them. It's to do with the nature of the arbitrary constant. I think they've used a formula myself for them to work it out, but that's why we've got a different looking answer to them, but it is absolutely equivalent. So that's the first thing in 1e. I reckon that was the mistake in 1e. Now 1f, I'm going to do this again because look what mistake I made here. I'm going to rub out this because this is all wrong. What I did was I wrote it down correctly here, but then put it over x minus 2 squared and completely clowned up. So that's why I'm doing this video all again. So let's just get rid of all of that. Because I was like, at first, oh, I'm sure they've done it wrong. But then I looked carefully and just realized it was one of those classic blunders where you just miscopy the question, really. So let's get it right this time. Let's see if we can end up with the same answer as them. So in 1 part f, naturally, we've got to write it in partial fractions again. But let's make that an x minus 1 squared and an x minus 1. So it is the same as the question, as I believe that's what the question was. So what are we going to get? We're going to get, firstly, I hope you're happy with this format. It's a repeated factor partial fraction, so you've got to get the format right. It's going to be a over x minus 1 squared plus b over x minus 1 plus c over x plus 4. And then we can start saying, okay, so 2x is identical to a times x plus 4 plus b times by x plus 4 x minus 1 plus c times by x minus 1 all squared. And let x equal minus 4, I guess. We're going to get minus 8 is equal to 0, 0. Minus 4 minus 1 is minus 5 squared, 25c. And so c must be minus 8 25ths. That's better because we've got 25ths kicking around there. And look, there's an 8 25ths there. But it looks like c is minus 8 25ths. What are we going to get for when we let x equal 1? Well, we're going to get 2 equals 5a. And then that's 0 and that's 0. So a is 2/5. And now for the last one, you could just let x equal anything you like. I'll show you a quicker way of doing it though. Because we've got bx squared plus cx squared here, you're going to have like b equal to minus c. And so b is going to be 8 25ths here. But I'm guessing that you probably would have done let x equal 0 or something like that. And you would have got 0 equals 4a, which is 8/5. And then you would have got minus 4b, which is what we're looking for. And then you would have got plus c, so minus 8 25ths. Maybe you would have times everything by 25 there. So you would end up with 40 minus 100b minus 8. So we get 32 over 100, I think, for b. But that is, of course, 8 over 25. See, I told you. You're going to get 8 25ths. You can see that one quicker, though, by equating coefficients. Bx squared plus cx squared there equals 0x squared on the left-hand side. Sorry, one moment. I need to take a sip of coffee. Thank you. Okay. Sorry, that was an emergency. It helps me think. It helps me think. I'm certain of it. Sorry, this is just down here is part of the answer I got wrong earlier after making a terrible blunder. Terrible blunder. Honestly, I'm beating myself up about it now. Okay, so we're now in a position, we hope, where we can integrate this thing. We know that we're really going to be integrating. If I just put that on the screen so I can see it, we're really going to be integrating 2/5 x minus 1 to the minus 2. And then we've got plus 8 25ths of 1 over x minus 1 minus 8 25ths 1 over x plus 4 with respect to x. And now I can actually integrate that. It's probably this term which is going to maybe stress you out the most, but remember, if you're ever integrating ax plus b to the n, and n isn't minus 1, it only works when an n isn't minus 1, you can just increase the power by 1, because it's a linear function, and divide by a times n plus 1, plus your constant c. So that's what I'm going to use to integrate this. It's going to be 2/5 minus 2/5 x minus 1 to the minus 1, according to that formula there. And then we're going to have plus 8 25ths ln x minus 1 minus 8 25ths ln x plus 4 plus a constant c. And I'm just going to have a look if that is the same as this. It looks the same to me. Well, I think they might have a sign error there actually. We've got 8 ln x minus 1 minus 8 25ths ln x plus 4. I'm pretty, yeah, I'm one. Oh no, hang on, have they checked? Oh no, look. See that x minus 1 and 1 minus x? Yeah, it is exactly the same. Just to show you that that is exactly the same, what I could do is, firstly, can you see that that's got 5 over 25 is just 1 over 5th, so that's really 2/5 1 minus x. Well, this is really 2/5 1 over, and I can switch around the x minus 1 to 1 minus x and times in the negative, if you see what I mean. So that is the same as what they've got, and then the 8 25ths is obviously what they've got. So they're just looking slightly different, the answers. Minus 8 25ths ln x plus 4 plus a constant c. And yeah, I could easily now write it in that format. I hope you can see that, Asandi. That is now equivalent to the red writing, because that times that equals 2/5 1 over 1 minus x, and that times that is 8/25 ln 1 minus x, so on and so forth. Oh, you might be worried about 1 minus x and the x minus 1 here. You don't have to be, because this is a modulus. Uh, when you integrate with ln, you always get a modulus, and the modulus of x minus 1 equals the modulus of 1 minus x. So I think I can see a few reasons why this question's confused you. You see, the thing is with integration is often like you can do lots of strange things happen in integration. The fact that you always need a modulus after ln, I think that could confuse you here, and also they've done a cheeky plugging the minus in and applying it to the denominator, and therefore switching round 1 minus x into x minus 1. But I hope that makes sense, and I hope you can see, I suspect that what you'll see is actually you were doing it right, but the answer just looked a bit different. Okay, thanks for listening, and keep up the hard work, Sandy. Bye bye.